For learning assessment 8.12, problem statement is if V0 is equal to A to the angle of 45 degrees, compute Vs. We'll be utilizing our problem-solving strategy entitled AC Steady State Analysis. And if we look at that, for relatively simple circuits here, which we have one that's a source, we're going to use things like Ohm's law and impedances and Kirchhoff's laws to solve for Vs. So we have a voltage over here. We're looking for a voltage over here. And what we'll do is we'll just start using Ohm's law and Kirchhoff's law. So for instance, right away we can calculate this current we'll call I3. And if we look, then I3 is A to the angle of 45 divided by 2. So that's 4 at an angle of 45 degrees amps. Okay, so we had already defined I3 here. This is also I3 because if we apply Kirchhoff's current law there, we can see that has to be I3 down in that direction. Now, if we look, for instance, at the voltage V1, which is here, we can now use KVL around this loop. So if we apply KVL around this loop to calculate V1, we'll have V1 is 2 minus J2 times I3. Okay, so that's 2 minus J2 times 4 at an angle of 45, which is 11.31 at an angle of 0. And now we can calculate I2, because now I2 is V1 divided by J2. So we have 11.31 at an angle of 0 divided by J2. So that gives us 5.66 at an angle of minus 90, which can also be written as minus J 5.66. Now if we apply Kirchhoff's current law here, we'll see that I1 is I2 plus I3. So we have minus J 5.66 plus 4 at an angle of 45, which is 2.83 minus J 2.83 amps. Now we can apply Kirchhoff's voltage law around this loop to come up with an expression for V sub S. So V sub S is 2I1 plus V1, and we have 2 times 2.83 minus J 2.83 plus 11.31 at an angle of 0. And for Vs, that gives us 17.89 at an angle of minus 18.44 degrees.